Hey, before we get started, I want to do a little housekeeping. So, you know how I used to do 2 chapters a week? I would do chapter, let's say 4, part 1, and then chapter 4, part 2. Well, I'm going to combine it, and it's going to be one chapter for the week. So, so this gives us an opportunity to do on a Tuesday, let's say Security Plus, Thursday, A Plus, which is a new series that I want to start. And then Sunday it'll be like a fun day, and we can do the history of modern technology. So I'm going to combine the episodes now. It's because I'm on the Podmatch network, and also my RSS feed Buzzsprout. In order to get ads, it has to be a certain limit. It has to be 23 minutes. So I'm going to make all of these shows at least 23 minutes, maybe longer. I don't know if you guys like them longer or shorter. If you do, just let me know. But that's the reason why I combined chapter 1 and chapter 2. And then on Sunday, I'll combine 2 stories. So instead of doing one story on the history of modern technology, I'll do 2. I'll do one back to back. That way, the total is 23 minutes, and I can meet all the requirements that everybody wants me to reach, and hopefully we build this community, and I can do this for a long time. Now that have myself set up for success, and I have which days I'm going to do it and how many I'm going to do a week, and then I have a lot of time in my schedule to do all this stuff. Hopefully you give me the opportunity to come back. I lost a lot of fans not doing it for 14 months. So hopefully everybody will come back and they will continue to listen. So without further ado, here's the next episode. And welcome to Technology Tap. I'm your host, Professor J. Rod, and today we're diving into the world of IT specialists, troubleshooting, and the very heart of the computer, the motherboard. Now, whatever you're a student preparing for the CompTIA A+ certification, someone already working in IT, or just curious about what goes on inside these machines used every day, this episode's for you. We'll explore what it means to be an IT specialist, the skills you need, the structured methodology behind troubleshooting, and then roll up our sleeves and step into hardware world, talking cables, connectors, motherboards, and expansion cards. By the end, you not only understand the concepts, but you also see how they connect to the real world and to your exam prep. So grab a notebook if you're studying, or just sit back and enjoy the ride. Let's get started. When people ask, what does an IT specialist actually do? I usually say an IT specialist is a problem solver. That's in its simplest form. Every day brings a new challenge. One moment you're helping a user recover their password. The next moment you're diagnosing a network outage that keeps an entire office offline. There is no routine in this role. That's what makes it exciting, and also what makes it stressful. IT specialists are often the unsung heroes of the workplace. Let me tell you a quick story. Years ago, I was working on a college campus, and it was registration week, one of the busiest time of the year. Suddenly, the registrar systems went down. Students were lined up, panicking because they couldn't register for their classes. Staff members were on the edge. Everyone looked to IT. Now, they could have panicked, but instead, they took a deep breath, remembered their methodology, and began systematically diagnosing the problem. Within minutes, they had the system back online. Later, one of the staff members said, "You saved us," referring to the IT. As I always say to my class, always be ready for the unexpected. Now, what makes a good IT specialist? It's not just about technical knowledge. Sure, you need to understand the hardware, software, networking, cloud, and security. But the skills and ability go far beyond that. First, as I always tell my students, it's communication. You need to be able to explain what you're doing in both written and oral form. Sometimes that means telling your boss in plain English why their laptop is running slow. Sometimes it means documenting in a repair ticket so another technician can follow up. Second, organizations. Think of your work space like your brain. If it's cluttered, finding the right tool or part becomes a nightmare. A clean, organized environment makes problem solving faster and more efficient. And third, problem solving as a process. Not just throwing darts at the wall, but using a structured, step-by-step approach. We'll get into that in the next segment. So, to summarize the first section, IT specialists are problem solvers, communicators, organizers, and lifelong learners. And if you're preparing for CompTIA A+ exam, keep in mind that the exam doesn't just test what you know, it tests how you think. Critical thinking is very involved in these exams. And this series, these A+ series that I'm doing in conjunction with the Security Plus that I'm running parallel, you will be able to take these podcasts and listen to it, and hopefully it will help you with your exam when you go and take the exam. All right, let's move to the detective work of IT, troubleshooting. CompTIA outlines a 6-step troubleshooting methodology, and it's one you should memorize not only for this exam, but also for real-world practice. And also, this stuff scaffolds, using an education term. So whatever you learn here, it's in Network Plus, it's in Security Plus, it's in Cloud, right? So you could always use it. Step 1, identify the problem. That might sound obvious, but it's critical. Gather as much information as possible. Ask the user, what error message did you see? When did it start? Did you change anything recently? Has anyone else experienced the issue? Let's imagine a user's laptop won't turn on. Before jumping into theories about bad motherboards or fried CPUs, check the simple things. Is it plugged in? Is the power strip switched on? Is the battery charging? This step alone could save hours. And with CompTIA, they always want you to try the simple stuff first. You try the simple stuff first, then you try the hard stuff. Step 2, establish a theory of powerful calls. Maybe it's a bad power adapter. Maybe it's a dead battery. Maybe the RAM is loose. Step 3, test this theory. Swap in a different charger. Remove and reseat the RAM. Try booting without peripherals. See if your theory holds water. Step 4, create and implement a plan of action. If your theory is correct, decide how to fix it. Replace the battery, order a new power supply, re-image the system. Step 5, verify full system functionality. Don't just stop when the system boots. Make sure the issue is fully resolved. If you replace the hard drive, test the operating system, the applications, the network connections. Step 6, document everything. This might be the most overlooked step. Write down what issue was, what you tried, what worked, what didn't. This documentation helps your team in the future and builds a knowledge base. Here's a real-world example. I once got a call about a dead PC. The user's solar wouldn't turn on. I arrived, pressed the power button, nothing. I checked the back, saw the power cable dangling on the floor, plugged it in. Problem solved. A $10 fix. Always question the obvious, right? And here's an exam tip. Expect a scenario question where you have to choose the next logical step. If they describe a computer that won't boot, don't jump in to replace the motherboard. Start with identifying the problem and always use the super simple stuff first, because that's what CompTIA is looking for. So always go for the super simple stuff. Check, right? You want to check the cables. You want to check, the video cable, right? The power cable, the video cable. It's the super simple stuff. Check that first. Now that we covered the human side of IT and the troubleshooting mindset, let's step into the hardware world. Inside the PC case, you have components, motherboard, CPU, RAM, storage, and then you have peripherals. Peripherals are the device that add functionality. Printers, monitors, external drives, keyboard, and mouse. Let's talk about USB, Universal Service Bus, and how we connect peripherals. USB 1.0 gave us 1.5 megabits per second transfer rate. Painfully slow by today's standard. USB jumped to 480 megabytes. USB 3 gave us gigabyte speed, and USB 4 now reaches up to 40 gigabytes per second. That's faster than some network connections. Here's a real-world tie-in. The European Union now requires smartphones to use USB-C. Why? Because it's universal. One charge for all devices reduces waste and makes life easier. Display cables are another key topic. VGA's analog, old school. HDMI gives us crisp audio and video only through a single cable. Doesn't give us data. DisplayPort is favored by gamers and professionals because it supports high resolutions, refresh rates, and daisy chain multiple monitors. And then there's Thunderbolt. Regular Thunderbolt 3 and 4, using USB-C connectors, can push data at 40 gigabytes per second. Perfect for external graphic cards, high-speed storage, and professional video equipment. Apple once used a proprietary Lightning connector for iPhones and iPads, but even they are shifting towards USB-C. If you buy a modern iPhone in Europe, you'll likely see a USB-C instead of Lightning, and here too if you buy it in the US. So whatever you're setting up a desktop, building a gaming PC, or working in enterprise IT, cables and connectors matter. Get them wrong, and you'll be chasing ghosts. Next, the motherboard. Now, let's head to the star of the hardware world, the motherboard. The motherboard is the central nervous system of the computer. It connects the CPU, memory, storage, expansion cards, and peripherals. It's also where the power and data flow. Without it, your PC is just a collection of parts. Major manufacturers include Asus, MSI, ASRock, Intel, and Gigabyte. Motherboards come in different form factors. ATX, the standard size, about 12 by 9.6 inches. Micro ATX, a smaller version, at 9.6 by 9.6, and mini ITX, even smaller, 6.7 by 6.7, often used in compact build. Think of it like vehicles. ATX is a full-size pickup, micro ATX is compact, SUV, and mini ITX is a sports coupe. Installing a motherboard is a process. First, review the documentation, install the I/O shield in the case. Those are the things where that plastic shield where you put like the keyboard and the USBs through in the back of the computer, that's the I/O case. Insert standoff to keep the board off the metal case. That's you put them on the case, the motherboard case. You put the standoffs first and then you put the motherboard on top. Pre-install the CPU and the RAM if you can. It's easier if you do it outside the case. Align the board, secure it with screws, and then connect power cables, storage devices, and front panel headers. Finally, manage your cables for airflow and aesthetics. Here's a story. I once installed a motherboard but forgot one standoff. That caused the board to short against the case. The system wouldn't boot. Lesson learned. Double check your standoffs. Electric static discharge is another risk. Always use grounding strips or mats. And keep parts in anti-static bags until you're ready. A single static zap can fry a dedicated motherboard. Now, I've never used a grounding strip or wrist strip to ground myself, but it's in the exam. So you should do it and you should learn it, right? When you get experience, then you do whatever you want. But when you're first starting out, do it the way CompTIA wants it. Motherboards aren't just about basic. They also support expansion. Video cards, GPUs, handle graphic processing, whatever for gaming, 3D modeling, or machine learning. Capture cards let you stream or record video feeds. Sound cards provide advanced audio features for professionals. Network interface cards expand connectivity from copper to fiber to wireless. Now that we have legacy connectors, VGA and DVI are still around in some offices, even though HDMI and DisplayPort have taken over. Serial cables with the DB9 connectors are dinosaurs, but you still find them on older industrial equipment. Why does this matter? Because as an IT specialist, you might walk into an environment that mixes brand new hardware with devices that are 20 years old. Knowing how to recognize and connect these legacies is still a valuable skill. So what did we cover today? We looked at the role of the IT specialist, the hero of problem solving. We broke down the 6-step troubleshooting methodology. We explored peripherals, cables, and connectors. We dug into motherboard, its functions, form factors, and installation. And we wrapped up with the expansion cards and legacy connectors. Now, before we stop, I am going to give you 4 questions, right? I'm going to say the 4 questions, and we're going to see how much have you learned, how much have you memorized. Hopefully, you'll get 4 for 4. But if not, there's always next episode. All right, here are your 4 questions. I'm going to read them twice, and then I'm going to give you the answer and then an explanation of why. All right, question 1, IT specialist role. A user calls the help desk and says that the monitor is blank, even though the computer seems to power on. As an IT specialist, what's your first step in troubleshooting? A, replace the monitor immediately. B, ask the user if the monitor power cable is plugged in. C, order a new video card. D, reinstall the operating system. I'll read it again. A user calls the help desk and says their monitor is blank, even though the computer seems to power on. As an IT specialist, what is your first step in troubleshooting? A, replace the monitor immediately. B, ask the user if the monitor's power cable is plugged in. C, order a new video card. D, reinstall the operating system. The correct answer is B, ask the user if the monitor cable is plugged in. CompTIA emphasized the first step is to identify the problem. That means gathering simple, obvious information first before jumping into complex solutions. Always check basics like power, cables, and connections before escalating. It's always the simple, stupid stuff, right? You ever heard that word, keep it simple, stupid? That's kind of like CompTIA's model, but they're not going to say stupid. But you want to always check the simplest things first, because it could be you spend hours chasing your tail and it's something really dumb. I have done that. So you don't want to do that. All right, question 2, troubleshooting methodology. You tested a theory and confirmed that a loose RAM module is preventing a PC from booting. According to CompTIA's troubleshooting methodology, what should you do next? A, document the findings. B, establish and implement a plan of action. C, escalate the issue to another technician. Or D, reproduce the error for the user. I'll read the question again. You have tested a theory and confirmed that a loose RAM module is preventing PC from booting. According to the CompTIA troubleshooting methodology, what should you do next? A, document the findings. B, establish and implement a plan of action. C, escalate the issue to another technician. Or D, reproduce the error for the user. And the answer is, drum roll please, I'll give you 5 seconds. 5, 4, 3, 2, 1. And the answer is B, establish and implement a plan of action. Once your theory is confirmed, the next step is to create a plan and resolve the issue. In this case, reseating the RAM or replacing it is the logical next action. Documentation comes last, not immediately after testing. All right, hope you got that right. Now we are on to question 3, cables and connectors. A technician is connecting a new external storage drive to a workstation that requires 40 gigs connection over a USB-C interface. Which standard should be used? A, USB 2.0, B, USB 3.0, C, USB 3.2 generation 1, or D, Thunderbolt 3. I'll read it again. A technician is connecting a new external storage drive to a workstation that requires 40 gigabytes of connection over a USB-C interface. Which standard should be used? A, USB 2.0, B, USB 3.0, C, USB 3.2 generation 1, or D, Thunderbolt 3. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the answer is D, Thunderbolt 3. Thunderbolt 3 and 4 both use USB-C interface and support up to 40 gigabytes transfer speed. USB 2, 3, and 3.4 generation 1 all offers slower speeds, maxing out between 5 and 20 gigabytes. I will tell you one thing about cables, and this is in general with all type of PC. You can put a USB 2 device on a USB 1 slot, but it's going to run at the 1 slot. It's going to run at the USB 1 speed. So, for example, if I have a USB 3.2 that runs on 20 gig device, and I plug it on a USB that runs at 5 gigabytes, is maxed out at 5, it's going to run at the 5, right? It'll work, but it's going to run at the lower speed. It's always going to be like that in IT. When you have two speeds and they don't match exactly, it's always going to run at the lower speed. Always, always. All right, last question, motherboards and expansion cards. A technician is installing a new motherboard in a desktop case. Which of the following must be installed to prevent shorting the board against the case? A, heat sinks. B, standoff. C, I/O shields. D, thermal paste. I'll read the question again. A technician is installing a new motherboard in a desktop case. Which of the following must be installed to prevent shorting the board against the case? A, heat sink. B, standoff. C, I/O shield. Or D, thermal paste. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the answer is B, standoffs. Standoffs physically separate the motherboard from the case, preventing electrical shorts. Heat sinks and thermal paste are for cooling the CPU, and the I/O shield is for lining ports on the back of the case. None of these prevent shorts. Now, did you get all 4? Hopefully you did. Fingers crossed that you did. But if you didn't, don't worry. We will be back next week to do another chapter on A+. All right, so what did we cover today? We looked at the role of an IT specialist, the hero of problem solving. We broke down the 6-step troubleshooting methodology. We explored peripherals, cables, and connectors. We dug into the motherboard, its functions, form factors, and installation. And we wrapped up with expansion cards and legacy connectors. If you're preparing for the CompTIA A+ exam, these concepts you'll see again and again, not just in test questions, but in your real-world IT career. Next week on Technology Tab, we'll dive into the CompTIA A+ series. We'll dive deep into storage technology, from spinning hard drives to SSD to NVMe and beyond. Thanks for joining me today. Don't forget to subscribe, and as always, keep tapping into technology. This has been a presentation of Little Cha-Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. You can follow me at TikTok at Professor J Rod, that's JROD, or you can email me at ProfessorJRod, JROD, @gmail.com.